All right, so now we're on the back side of notes and we're going to be doing division. However, back in the day, we learned that you actually never divide fractions. You do something called a keep, change, flip. You keep the first fraction exactly how it is. You change the division sign to multiplication. Okay, and you flip or you do the reciprocal of the last fraction. Okay, and then you follow your rules for multiplication that we just got done doing. So in number 6, we start off with monomials again. No binomials or trinomials in here, and so therefore it doesn't need to be factored. But we are going to change this multiplication division sign to a multiplication sign. And we're going to take the 8x and put it on the top, and the 24y squared and put it on the bottom. And then we're going to get rid of that so we don't think that it's still there. Okay. And remember what we do when we multiply two fractions with monomials, we just go across the top, we go across the bottom. Again, you could do something called cross reducing, but I find that you guys do a better job with just getting the total and then reducing. All right, so up on the top, 30 times 8 is 240. Looks like x, y to the 6th. On the bottom, 20 times 24 is 480. X to the 3rd, y to the 2nd. Okay. Again, your calculator will help you reduce your numbers here, your coefficients. So if you type in your calculator 240 divided by 480, okay, math bracket, and you're going to see that actually 240 is half of 480. So 240 goes into 240 once, 240 goes into 480 twice. Okay. Next up are the x's. This x on top is going to be completely gone with one of the x's on the bottom, leaving x squared. Okay. Y squared on the bottom will be completely gone, and it will leave a y to the 4th up on top. Okay. I'm pretty sure that that is all I have left. So up on top, I have a 1y to the 4th, or just a y to the 4th. And on the bottom, I have a 2x squared. And there is my final answer. Okay. Next one up in number 7. So now we're back to having binomials here. And so we have to make sure that we factor them before we cancel anything. Okay. We're going to go ahead and do the same first step. We're going to change that division sign to a multiplication dot. And I'm going to flip the second fraction. Okay, and now I'm going to go ahead and factor anything I can possibly factor. At the top of my fraction here of my first one is a d2ps, and it's going to factor into x plus 5 and x minus 5. On the bottom, that's a monomial of 5x squared and cannot be factored. Up at the top here, which was used to be on the bottom, is a greatest common factor of x. Pull it out and be left with x minus 5. On the bottom, there's nothing to be factored. However, that binomial squared really means 5 minus x times itself 5 minus x. And I'm going to write it out twice so I can see its factors so that I can reduce possibly both of them with something else. Okay. And let's see, what can I reduce? I see that situation not only once but twice. Here I have an x minus 5, and here I have a 5 minus x. The 5s are opposites, the x's are opposites, and so this is one of those cases where you can reduce, but you have to make sure that you reduce it to -1 and leave that negative behind. Okay? You have that same situation here again, where here you have x minus 5, and here you have 5 minus x. The x's are opposites, the 5s are opposites, so again, they're going to reduce to a -1, and so you'll have to leave another negative behind. However, the two negatives, two negative and a negative, actually make a positive, all right? So we actually don't need either one of those anymore. Okay. Anything else? Yes, I see one more thing. This x here, okay, is going to be completely gone with one of the x's from the x squared down here, leaving an x on the bottom, all right? And I'm going to highlight what is left. It looks to me like I have an x plus 5 here and nothing else on top. On the bottom, I have the 5 and the x and nothing else. And so we're going to go ahead and write what's left over, which is x plus, oops, not in highlighter. I'll have x plus 5 on the top, and on the bottom I have a 5x. Okay. And again, the reason why those 5s won't reduce or the x's won't reduce is because up here, that x and 5 are called terms, where this x and this 5 down here are called factors. They have different operations in between, okay? And you can only cancel or reduce factors with factors. A couple more. Number 8. Okay. Again, it's a division problem, so I'm going to change the division sign to multiplication, and then we'll go ahead and flip that second fraction. Okay. Now we did our keep, change, flip, and we do have binomials in here, so we have to make sure that they're factored. Up at the top, that's a D2PS, and it's going to factor into x plus 2 and x minus 2. On the bottom, that's a greatest common factor of 2. Pull it out, and you're left with x minus 3. Keep the multiplication. Up at the top, we have x minus 3. No types of factoring work on that, so we're going to go ahead and leave him. And same thing with the bottom, 2 minus x. No types of factoring work on that. Okay. And now we're going to go ahead and look for our common factors. And I do see a pair that is exactly the same. I have an x minus 3 here and an x minus 3. And here I have that situation where I have 2 minus x and x minus 2. If you notice, my x's are opposite signs of each other. The 2's are opposite signs of each other. And so these can reduce, but they reduce to -1. And so you have to leave the negative sign behind. Okay. I don't think I have anything left to reduce. And so I have the negative in parentheses is x plus 2. The x plus 2 must stay in parentheses unless you distribute the negative to it. Okay. I don't recommend distributing the negative, therefore I recommend keeping those parentheses, all right? But if you did distribute the negative, it would turn into a negative x minus 2 over 2, okay? You could also, instead of putting the negative in the numerator, you could also put the negative in the denominator. And since the denominator only has one term in there, you wouldn't need any parentheses. So you're going to see all 3 of these answers are exactly the same, but each one of them has a different look to them. And so you have to be very, very, very careful. All right, next question up, number 9. Again, it's a division problem. So we're going to go ahead and change that to multiplication, and we will flip this fraction. All right. Taking a look, we do have binomials and a trinomial in there, and so they all have to be factored in order to cancel common factors. We're going to go ahead and give this guy the frowny face. He's a hard trinomial. We're going to set up our x box, and we're going to multiply to -35, and we're going to add to 2, and hopefully you know the numbers already are 7 and 5. And the 5 has to be negative in order to get the positive 2, okay? Remember, I gave him a frowny face for a reason. So while I'm over here in the corner with my x box, I'm going to go ahead and rewrite my 35x squared. I'm going to take my minus 5x next, then my plus 7x, and then the minus 1. I'm going to go ahead and regroup. Out of the first group, I can pull out a 5x, and I'll be left with 7x minus 1. Out of the second group, I can pull out a positive and nothing else in common, so a 1. And left over would be a 7x minus 1. And so 7x minus 1 becomes my first factor, and 5x plus 1 becomes my second factor. Okay? And so now I'm going to come back up here, and we're going to replace that trinomial with my factored form, okay, that I have down there. On the bottom here, I have a greatest common factor of 3. I'm going to pull it out and be left with 5x plus 1. And keep my multiplication dot. Up at the top here, I have a greatest common factor of 6. If I pull it out, I have a 1 plus 7x left. And on the bottom, I'm going to go ahead and greatest common factor of 2 and be left with 1 minus 49x squared, which hopefully if you have good math eyes, you can see that that's a difference of 2 perfect squares. And so I'm going to bring down my 2 and be left with 1 plus 7x and 1 minus 7x. And just draw one single line through there so you can still read my work, but know that it is been refactored. Okay. All right, so we're looking for any common factors that are exactly the same, and I see a pair right off the bat. I see a 1 plus 7x, and I see a 1 plus 7x, so they're reduced to 1. I also see a 5x plus 1 and a 5x plus 1. And then we have that case where I have a 7x minus 1 and a 1 minus 7x. Notice my 7x's are opposite signs. My 1's are opposite signs. And so this is the one that reduces to -1. So just leave your negative sign behind. Okay. And now we're looking for small monomial terms. And I see a 2 and I see a 6, but I also see a 3 and a 6. And I know that 3 times 2 on the bottom there makes 6. So you can cancel those out in any way. I think a lot of people would do 2 goes into 2 once, 2 goes into 6 3 times. And then you can say, oh, here's a 3 and here's a 3. Okay, and cross reduce those. Taking a look at what I have left, I don't think it's much. I have a negative sign. There's nothing left on the top. And there is also nothing left on the bottom. So I can't just write negative. I know that's all I left behind. You just have to remember that the negative is really just a -1. And so there's my answer. Okay. We got 2 more to go. And again, very first thing, change the division to multiplication and go ahead and flip that second fraction. All right, so we have binomials and trinomials, and remember, guys, they all have to be factored, okay? So up at the top, that's a D2PS, and it's going to factor into 3x plus 1 and 3x minus 1. Okay. On the bottom, we're going to go ahead and throw him the frowny face because that is a hard trinomial, and there is no way out of it. I'm going to go ahead and do my x box down here and hopefully out of the way. My multiply is going to be 6, and my add is going to be 7. And I'm going to find that the numbers are 6 and 1, and they're going to stay both positive. And while I'm down here, I'm going to go ahead and factor that harder trinomial. So I'm going to rewrite 3x squared. I'm going to put plus 6x, then plus 1x, and then my last term of plus 2. Okay. I'm going to group and group. And out of the first group, I'm going to pull out a 3x. Left over will be an x plus 2. And out of the second group, I'm going to take out a plus 1, and left over is x plus 2. Okay, x plus 2 becomes my first factor. Guys on the outside, 3x plus 1 become my second factor. Okay, so now I'm going to go ahead and replace that hard trinomial with its factors of x plus 2 and 3x plus 1. Keep my multiplication. And up at the top, that's a nice easy trinomial. So I might throw my x box right next to him, multiply to be a -14, and add to be a -5. And hopefully you find the numbers to be -7 and 2. Right? And again, he is a nice easy trinomial, so we can go right to the factors with those numbers and have x minus 7 and x plus 2. Okay. Next one up on the bottom, greatest common factor. Pull out a 5 and be left with 1 minus 3x. All right, time to look for the factors that are exactly the same, and I see them, 3x plus 1 and 3x plus 1. Okay. I also see an x plus 2 and an x plus 2. I also see a 3x minus 1 and a 1 minus 3x. Notice the 3x's are opposite signs, the 1's are opposite signs, so this is one of those ones where we reduce to -1 and we leave the negative behind. I don't believe anything else will reduce. So I'm going to highlight what I have left on top and what I have left on the bottom. And we're going to go ahead and write down our answer as negative. In parentheses, x minus 7. I told you didn't have to distribute. If you do distribute, then you can lose the parentheses. If you don't distribute, you got to keep that negative on the outside and the x minus 7 on the inside. Okay, over 5. And that is a fine answer. It is not the only answer. Again, you could have distributed and got negative x plus 7 over 5. Or you can take that x minus 7, take him out of his parentheses because the negative could go with the 5 on the bottom. All right, any of those are exactly the same answer. All right, last one here on this page. So going up to the top, we see that it's division. We're going to change that to multiplication. And we're going to go ahead and flip this fraction. And And we are not going to do this one because that is a difference of 2 cubes, and I did not teach you it. So we are going to cut 11, and this one is finished, okay? Because we can't do that one just based on the year. We cut a topic called cube factoring, and there is a cube in there. So we are going to cut that one out. All right, guys. So that is the end of this lesson, and I will see you guys in the next one.